Alright, and so for our last problem, it is asking us to look at converting 1 square root of 3 and 1 to polar coordinates because they are rectangular right now. And the way we do that is we set r and theta. R is equal to the square root of x squared plus y squared, and theta is the tan inverse of y over x. Solving for the first one, we have square root of 1 plus third is 3 squared. We can get rid of that square root for the 3. So r is equal to 2 for the first one. Now we want to find our theta. You can go ahead and forget about the 1 since anything divided by itself, or divided by 1 is itself, so the tan inverse of square root of 3 is going to be 60 degrees if you use your unit circle. That means our theta is 60 for the first one. Moving on to 1, r is equal to the square root. We can forget about those squaring the 1's. R is equal to the square root of 2. And our theta is tan inverse 1 over 1. Theta equals tan inverse of 1, which if you use your unit circle will be equal to 45. And that takes care of part A. Now part B is asking us to find the area of one loop of a 4-leaf clover, or a rose, depending on how you look at it or draw it. And the equation they give us is r is equal to cosine of 2 theta. Now graphing that graph will look something like this. Kind of like a bow tie or rose or flower. Now all we want to do is focus on one square or one rose at a time, one leaf. We want to find the area of this rose. And the area is equal to the integral of 1/2 r squared d theta. Now we know that cosine is bounded between negative pi fourths and pi fourths. So now we have our limits. So our new area function is going to be the integral of negative pi over 4 to pi over 4 1/2 cosine squared of 2 theta d theta. Now if you remember early on calculus, you'll recognize that this is symmetrical, meaning we can add a 2 to the front, get rid of our lower limit with 0, and we have even more simplification here. Now this is a pretty easy integral. If we just remember that cosine squared x is equal to 1 minus cosine 2x over 2, we can apply this formula to what we have, which means x is equal to 2 theta, and that means 2x is 4 theta. So the integral 0 to pi over 4 of 1 plus cosine of 4 theta over 2 d theta. We can take out the half. And now we can just integrate normally. This is going to be equal to 1/2 times theta plus sine 4 theta over 2, evaluated from 0 to pi over 4, which is going to equal 1/2 times pi over 4 plus sine of 4 pi over 4. Those are going to cancel. Minus 0 plus sine 0. And all of this is going to evaluate to 1/2 times pi over 4, which is in turn equal to pi over 8. And that is our area of one of the leaves on a 4-leaf clover. And that is the end of problem 11.